Alright, welcome to a video for section 11.5 from Math 2, which is on factoring x squared plus bx plus c. Before we get to the actual factoring, we're going to start by looking at some patterns. So part 1, looking for a pattern. Here we have three different problems where we need to multiply. We have x plus 3 times x plus 5, x minus 4 times x plus 7, x minus 1 times x minus 12. First of all, what do these three problems have in common? If you said that they are two binomials multiplying so that you have to FOIL them, you would be correct, but there's more to it than that. You'll notice that there's no numbers in front of the x. Well, I guess you could say that there's a 1, but there's no number other than that. So this is what we're looking at. Okay, you know how to do this. Go ahead and multiply all three of these together. Write down what you got, and then we'll look at the pattern together. Okay, let's check your answers. For the first one, you should get x squared plus 8x plus 15. For B, we should get x squared plus 3x minus 28. And for C, we should get x squared minus 13x plus 12. If you need to fix anything, go ahead and pause the video and go ahead and do that. Okay, so let's look at the pattern that I hope you're starting to notice, but if you're not noticing it so far, in this case, remember that 1 was in front of the x's. There is no number in front of the x squared, although you could call it a 1. So this is a 1 in every single case, just an x squared. That's one part of the pattern. The second part of the pattern has to do with the yellow numbers that I've highlighted. When you're doing the middle terms, you get a 5x and a 3x, which combine to give you an 8x. And then this one, we get a 3x, we get a negative 13x. But what I want you to realize is that this number, this 8, that is 5 plus 3. And where do we get those 5, that 5 and 3? Those are these two numbers. And that is true for all of these problems. 3 is 7 plus negative 4, and negative 13 is negative 1 plus negative 12. We're taking the two numbers that are in these spots and we're adding them in order to get the yellow number, the number that's in front of the x. Okay, so then there's another pattern going on here, and that's with the last number. The 15 is the product of those two numbers. It's 3 times 5. 7 times negative 4. Negative 1 times negative 12. And that's a really important pattern for what we're going to do with this, which is to factor. Before we go on to the factoring part, I just want to show you what would it look like if it was not a 1x, but maybe it was like a 2x. So let's say we had 2x plus 3 times x plus 9. So this doesn't fit the pattern that we were looking at because we have a 2 right here. So if we were to FOIL that one, we would get 2x times x is 2x squared. 2x times 9 is 18x. Then we use the 3x plus 27. So two things are going to be different. We are not going to have an x squared anymore, we have a 2x squared. The next thing that's different is when we combine like terms here, we're going to get 21x. 21 is not 3 plus 9. It's not equal to that. It doesn't work. The only thing that really stays the same is the last term. The 27 is 3 times 9. But other than that, the rest of this doesn't really have a pattern to it. At least not the same pattern. In a later section, we'll talk about what's going on in these cases. But I just want you to show that this is not the same. Okay, so we're focusing on just when it's an x and an x. So x plus a number or minus a number times x plus a number minus a number. Okay, so part 2 of this is we're going to use the pattern to factor. So factoring is pretty much the backwards of what we were just doing. Okay, specifically, our goal in factoring is, well, let's just sort of define what factoring is. We can define factoring as the process of writing a polynomial as a product of its factors. And you can think of it as kind of like the reverse of foiling. Well, and other kinds of multiplication. But in this case, we're going to be looking at it as the reverse of foiling. So let's take a look at some examples. Okay, so our first example says factor x squared plus 10x plus 16. Well, factoring, as we said, was basically the reverse of foiling, and now that we know that pattern that we looked at from before, we know that if we have x plus or minus a number times x plus or minus a number, it will FOIL into something of the form x squared plus some number times x plus some number, where the number in front of x is the sum of the 3 and the 5 or whatever numbers, and the number at the end, the constant term, is always going to be the product of those two numbers. So we need to work backwards to figure out what those two numbers were. So we know it's going to be something of this form. Please note that not all factoring is going to look like this. It doesn't have to be two binomials, but I know that in this case it will be. So we know that this 10 comes from adding the two numbers, whatever they are. Okay, so these two numbers, we want to know what those are. So we know there's going to be an x here and here. And we know that because the number in front of here is a 1. If this wasn't a 1, these would have to be something a little different, such as maybe a 2x, like we saw in this this weird example here. Okay, so we know that 10 will be the sum of our two mystery numbers, and the 16 is the product of our two mystery numbers. Now, if this feels familiar, right, so that 16 would be like the 15, and then the 8 would be like the 10 was like the 8 in that first example. So if this feels familiar, it's because these are diamond problems. When we were learning this, we were practicing finding two numbers that multiplied to be a specific number and added to be a specific number. And in this case, we want to find two numbers that multiply to make 16 and add to make 10, because that's the pattern. So the 10 comes from over here in front of the x, and the 16 is the number at the end. And these two numbers that we find when we do the diamond problem are what go inside the binomials. So, do you know what those two numbers might be? If you said 8 and 2, you are correct. 8 times 2 is 16, 8 plus 2 is 10. And since they're both positive, I'm going to put plus 8 and plus 2. And there's the answer. Okay, and we can check our work by foiling. X times x is x squared, x times 2 is 2x, 8 times x is 8x, and then 8 times 2 is 16, and when we combine, we will get back the original problem. So you can see that they are reverse operations of each other. Okay, so in general, if you are factoring x squared plus bx plus c, it would become x plus some number, I'm going to call it e, times x plus some other number, f, where e and f are the numbers you get in a diamond problem where the product is c and the sum is b. Okay, so these numbers that we find are going to go here. So we basically have to set up the diamond problem. C is the product and B is the sum. All right, let's just try a couple more. And I'm going to put this in a nice big box because this is the key idea here. Okay, why don't you give these 3 problems a try? Or at least the first 2. If you're not sure what to do with C yet, then you can hang on to that one. All right, for the first 2 you should be setting up a diamond problem. For the first one, we want to find 2 numbers that multiply to make -10 and add to make 9. And for the second one, we want to find 2 numbers that multiply to make -30 and add to make -13. Can you find those numbers? So the answers to the first 2 are -10 and 1. So the factorization would be x minus 10 times x plus 1. For B, it would be x minus 15 times x plus 2. Just a quick note, each one of these binomials is a factor. Okay, each one is a factor. All right, let's talk about C. C is a little different. If you'll notice, there is a number in front of the x squared. That number is 4. It's not supposed to be a 4 if we're using this method. But perhaps you also noticed that there is a greatest common factor, which we learned about in a different video. The greatest common factor needs to be taken out first before we can do the other kind of factoring. And I'm not going to say that this is always going to work, as we'll learn later that sometimes it's not going to be a greatest common factor, so you have to factor it different. But in this case, there is a greatest common factor of 4. We can take the 4 out. So I'm going to take the 4 out before I start anything. I cannot take an x out because 24 does not have an x. So I'm going to divide each thing by 4, and I get x squared minus 5x plus 6. Now, what I have inside the parentheses here, that is factorable using this method. So let's find 2 numbers that multiply to make 6 and add to make -5. Those numbers are -2 and -3. So the final answer is 4 times x minus 2 times x minus 3. And we're done.